Okay guys, so today we are going to go through notes for 2.2. I know some of you are gone to the fair, and so we're just going to try to get this stuff out to you. We're basically going to be working at different ways to represent data, different graphs that we can use to represent them. The first one, the most common one, is called a histogram. You're going to think of it a lot like a bar graph is what it's going to look like, but it uses vertical bars with different heights to represent the frequency in a class. The class boundaries that we've been using to create our frequency tables, those class boundaries are on the horizontal or the x-axis. So here's what a histogram looks like. You can say, okay, from 99.5 to 104.5, and that right there, that 99.5 would be the boundary. Now, remember when we did this temperature deal, the lowest temperature, let me come down here and find this data, the lowest temperature was actually 100, and that's our class limit. Okay, if we're using that as a class limit, our class boundary would be at 99.5. And so we need to make sure when we label the bottom of a histogram that we're not using the lowest number in that set, but we're using the class boundary, right, or class boundary. And so making sure that we go to that half less and half more. So if we were going from 100 to 104, we're using 99.5 to 104.5. And then if you look at this, there were two states that had that as their high temperature, and so we went up to 2, whereas the next temperature region, frequency region or class would come up to maybe 8, and so on. And so we can look and see that this is a nice way to see that. Keep in mind, these are not these are grouped classes. We're using class boundaries to create this x-axis. We do not want to start right up against the x-axis. We usually leave a gap, okay, on the left to make it easier to read the graph. So histograms, they typically have that break there. Okay. Other types of graphs that we can use, one's called a frequency polygon. It displays the data by using lines that connect dots plotted for the frequencies at the class midpoints. The frequencies are represented by the heights of the points. Okay, and the class midpoint is represented on the horizontal axis. So one of the things we have to do this, if we go back to the data for the 50 states, I'm going to go ahead and help build this. It's actually in the textbook if you want to look, and we'll write these numbers down. But they're in example 2.2, but you can find the frequency polygon example on page 53. But what we're going to do here is put in some data. So first, we have to know the midpoint for each class. So the midpoint of 100 and 104 would be 102. The midpoint for 105 and 109 would be 107. Then we'd be at 112, then 117, then 122, 127, and 132. This is why it was important that we used those odd number class sizes. We wanted odd class widths so we could find the middles. Now the frequency from the table, if we go back through that data of all the high temperatures for the different states, between 99.5 and 104.5, because this is really not going to go from 100 to 104. It's that 99.5 to 104.5 that we're actually looking. Given, I mean, the reality is the data that we looked at didn't have any decimal values, but using that as our class boundary, looking for things between those, we would have 2 in the first one, 8 in the second one, then 18, 13, 7, 1, and 1. Okay. The reason that matters is now when I go to do the frequency distribution, the frequency for I'm going to use a frequency polygon. Okay. Our temperature is down here. Okay. We're going to label the x-axis with the midpoints. Okay. And so the midpoint, the first midpoint we're going to worry about was 102. The next midpoint should be 107. The next midpoint would be 112. And then 117, 122, and I think 127. There was a 132. and then out here. Okay, so first off, a polygon has closed sides. So even though we don't have a data point here, we're going to put a data point on the end to close our shape. We're also going to start not at 0, 0, but at a data point there, some point before 102. Usually we do it right in the middle. At 102, there were 2 data points, okay, that were between 99.5 and the 104.5. So over here I'd be at 2, and at 102 I'd put a dot. Now, were there 2 temperatures that were actually 102? The answer is no. But that is our midpoint, and so we're talking kind of averages here in our frequency polygon. 107 is the middle of that second section, and it had 8. So if that's 2, 4, 6, 8. So 107, I would be up to 8. I'm going to have to get all the way up to 18 on here, I think is my biggest one. 8, 10, 12, 14, 16, and we'll label 18 right there. Okay, so the frequency distribution for 112, that one had 18, so that's my big one. I'm going to come up here and draw that dot. 117 was, I think, at 13, which there's 8, 10, 12, 13 would be right in the middle here. Excuse my bad graphs on here. I'm just doing the best I can. 122 would have about 7, so that should be just under the 8. And then 127 was at 1, which would be down here, and 132 was at 1. Now here's the tricky part with this polygon. We're going to draw a straight line. Whoops, Mr. Welch, there we go. From one dot to the next. They're all individually straight sections. So I know mine are not straight at all, but imagine drawing your shape. Okay, kind of like this. Coming down, over, that's supposed to be flat, and then back down. So that's what a frequency polygon looks like. It's closed. It goes all the way down to the x-axis on both sides, and we see that we have our frequency diagram. An ogive or ogive, I don't know how to pronounce it. I'm going to say it, an ogive graph represents the cumulative frequency for the classes. So rather than having it go up to its high point and then working its way back down, an ogive graph has it works on the cumulative frequency. And so class limits are there. Class boundaries we know are the 99.5 to 104.5, and these upper class boundaries, okay, are the ones that are going to show up on the x-axis. So this would be up to 109.5, up to 114.5, 119.5. So on an ogive graph, we're going to use the upper class. Our frequency is the same: 2, 8, 18, 13, 7, 1, 1. But what's important is our cumulative frequency is 2, then 10, then 28, then 13 more would be 40, 50, 41, 41, 48, 49, and 50. And we might say that anything under 99.5 would be 0. So 99.5, okay, under the 99.5, there are 0 data points there, just to kind of identify how we're starting this graph out. So when we do the ogive boundary and the cumulative frequency, we're really just grabbing those two numbers. But when I go to graph this, okay, first thing I'm going to do, I'm going to start down here at 99.5. And then here I'd have 104.5, and then 109.5, 109, 114.5, and so on down the list. What's going to happen here is we're going to start at 0 because there are 0 that are below 99.5. How many exist below 104.5? Well, that number was just 2. So let's put 2 right there. So we're going to come up to 2. Now how many are under 109.5? Well, that's 8 more, right? There were 8 in that second class. So now we're going to be up to 10. 2, 4, 6, 8, 10. So there's 10. So here I'm going to come up to 10. This is a cumulative. It's going to only grow. This will not shrink or come down again. It's only a growing value at 114.5. That's when we added the other 18. So I'd be up here up to 28. Okay, so up here now I'm way up here. What you're typically going to look for or notice about an ogive graph is that as we come out and we add more, the next section goes up to 41. So I'd be up here to 41, wherever that is. It's going to be up here pretty high. As I keep coming up, as I get to these last sections, it's going to start shrinking because I'm not going to grow as much. I'm at 41. The next section goes up to 48, but that doesn't grow as fast as it did before, and so it's going to start to flatten out. And then the last ones, once I'm at 48, the last two only grow 1 to 49, and then again to 50. You see it has that sort of S-shaped curve to it. Most ogive graphs will have that S-shape structure to it. The idea is that at the end of the day, our frequency should end. We should end up at the total number of data points that we had, which was 50. We use the upper class boundaries. Okay, so we've got to make sure we're using those upper class boundaries. We'll start at the lower class boundary with 0 and work our way up from there. Okay. The last one I think we've got to talk about is a relative frequency graph. These were those numbers of how often each of those temperatures occurred. Okay, and this would be temperatures in Fahrenheit. When we talk about relative frequency, we're talking about basically the percentage. It's 2 out of 50, okay, right? Because it was out of 50 states. And so 2 out of 50 turns out to be 4% of the time. 8 out of 50 is 16%. 18 out of 50 is that 36, I think 36% of the time. 13 would be 26% of the time. 7 would be 14% of the time. And then we got 2% and 2%. Now if I added those all up, I should add up to 100% if I did that right. That makes 20, that's 56, plus this 4 makes 60, yep, and that's 40. Okay, on the bottom, we're going to use the midpoint values again. So I'm going to start here on the for my relative frequency graph. I am going to start with the x-axis starting at what is it? Was it 90? It was 100 to 104, so I'd use 102. Okay, I'm going to have a dead spot here. Okay, and then at 102, I want to be at 4%. So I'd have a dot there. Then the next number I think was 107. Yeah, it was 107 was the next midpoint. Remember we did those midpoints earlier on the other graph. The 104, that was that frequency distribution, the Polygon. 107 would represent the middle of the second group, which would be up to 16. So there's 8, 12, 16. So I'd have a dot there. Okay, and so a relative frequency graph, it's going to look, connecting our dots again, 112 is at 36%, so I'd come up quite high. But what we're really looking at here is just another representation to say, comparative to the group over here, 36%. This gives me an idea, if I look at a certain point, what percentage of people or temperatures would fit in that scale. So there's these different ways to model the data, different ways to show the data in a graphic form. It's really a question of what's more relevant. What are you looking for? Are you looking for, like with the ogive graph, this graph is really built around the idea of saying, hey, when we hit a threshold, like we say, okay, when we've hit 40 out of 50, we're good. And so you'd kind of say, okay, where does that happen? because you know everybody over here is above that norm, and we don't need to worry as maybe the same way about them. This could be like an income. Okay, at what point do we need to start supporting people or stop supporting people with taxing policy? So there might be a cutoff that we're looking for, and an ogive graph would give us a good visual there. A frequency distribution gives us a general idea of the shape of the data. Okay, how's it gathered? And similar with a histogram does the same, but it focuses on the class. Notice it focuses on the low class, high class, whereas the frequency distribution focuses on the average or the middle of a class. So it depends on where our focus is going to be and what we want to represent. So there's lots of different options, guys, and you just want to get comfortable with all of them. If you have questions, come into class and we'll talk about them and see what we can do.